Good day. Dear colleagues, we invite your attention to a report on the topic Parametric synthesis of 3D structure of CRR element of the metamaterial. Telecommunication miniaturization trends have intensified the search of approaches to the creation of electrically small antennas. At the same time, the technologies of microstrip antennas have reached their limits in terms of reducing the dimensions of microwave devices. As a result, one of the promising areas of ESA design is the use of metamaterials. As it known, metamaterials are substrates for printed miniature antennas and can reduce the size of the emitters, increase their passband and radiation efficiency. At the same time, the main task of improving the metastructures is the synthesis of such environments that would have minimal losses and almost insignificant dispersion properties, as well as provide a wide frequency band corresponding to the negative reflection index or double negative parameters, DNG. To identify a metamaterial as a DNG structure, it's necessary to evaluate its electromagnetic properties. Such an estimates come down to an analysis of the sum of the real part of the quantities epsilon and mu. As a classic example of the metastructure unit cell on the basis of which a negative reflection index can be achieved, accordingly a DNG frequency range can exist, the split ring resonator, SRR. To reveal all the possibilities of integrating ESA technologies and metamaterials, it is advisable to conduct an open optimization of the parametric of SRR structural elements, for example, through the use of 3D geometry. Considering that metamaterials are complex compositive structures, analytical solutions to access their properties become unapplicable. As a result, the role of fixed assets at the process of metamaterials designing is assigned to numerical modeling. Thus, the aim of work is to increase the efficiency of metamaterial using SRR by modifying its geometry. In this paper, a printed SRR was used as a prototype. Based on the considered model of the author synthesized the SRR variant based on the implementation of 3D geometry. The study of electromagnetic properties of the synthesized SRR variants was carried out taking into account the influence of geometric parameters, orientation and the size of conductor, axial rotation of the rings. In addition to a classic FR4, several materials options were considered. Taking into the presence of the SRR modification without a substrate, the influence of the tilt angle of the CRR ring around the OX axis on the frequency properties of the metamaterial unit cell model is analyzed. In turn, the rotation of the conductor around the OZ axis by 90 degrees led to an increase in the bandwidth with the DNG region. The value delta F is 8.64 GHz was achieved. Delta F DNG is 1.13. In addition, the CRR model was investigated by ring rotated by 90 degrees around the OY axis, with section of the CRR frames located on the OZ axis. This allowed us to obtain delta F 10.78 GHz and delta F DNG 1.9. Considering an obtained effect, the CRR layout option was studied in the most detailed, which differed by the deviation of the ring section in relation to the OZ axis by angle for up to plus minus 30 degrees. In this case, fluctuations in the value of delta F DNG occurred. As a result, the maximum effect was observed to the deviation angle of 20 degrees. The results obtained suggest the possibility of a slight decrease of the frequency range of the DNG region due to the use of the substrate material with a higher epsilon value. The analysis indicates an increase in the width of the DNG frequency range as the dimensions of the CRR constituent elements along the OY axis increase. To increase delta F, it is possible to introduce mutual rotation of CRR rings around the OZ axis. For instance, this made it possible to provide an additional increment of delta F to 500 MHz. So, to study the electromagnetic properties of the synthesized CRR variants was carried out taking into account the influence of geometric parameters. CRR with the conductor placed to the X or Y plane and its axis oriented perpendicular to X or Z is an effective solution that has led to the expansion of the DNG bandwidth and the low frequency region. The use of a conductor with a rectangle cross-section is advisable if its largest side is oriented perpendicular to the floquet ports. When determining the optional angle of inclination of the section plane for the CRR frames in relation to the X or Z plane, it is advisable to choose it within the range of 0 to 90 degrees. If we consider the synthesized CRR model as a template for creating a metastructure, then the cut width of the frame should be equal to the double thickness of the rings. To expand the frequency domain of the DNG and simultaneously shift it down in frequency, it is advisable to perform a mutual offset between the CRR rings. However, it should consider that it only makes sense to do within certain limits. It is concluding of my briefing. Thank you for your attention.